Now let us understand about these real numbers. Real numbers are broadly classified into two categories. They are irrational numbers and rational numbers. Again, these rational numbers are categorized as fractions, natural numbers, whole numbers, and integers. Again, these integers categorized as 0, positive integers, and negative integers. Let us understand about this. So here rational numbers and irrational numbers. So these rational numbers are in the form of P by Q, where Q not equal to 0 and P and Q are belongs to Z. What is this Z? Z is nothing but integers. Z is nothing but integers. This integers represented with Z. Real numbers represented with are rational numbers represented with Q and irrational Q dash are S. Natural numbers N, whole numbers with W. Let us see. What are the fractions? Fractions are like 1 by 2, 3 by 5, minus 7 by 9, and so on. These are all fractions. So here these fractions are in the form of P by Q. Numerator is P, denominator is Q. So here Q not equal to 0. So Q not equal to 0, we have to satisfy this condition. If Q equal to 0, that means denominator is equal to 0. As we know that if denominator is equal to 0, a number divided by 0 which is undefined. So here this denominator Q not equal to 0, and this P and Q both are belongs to Z. Z in the sense integers. Let us see what are the integers. So here natural numbers are 1, 2, 3, 4, and so on. These are natural numbers. So now these natural numbers are also part of this rational numbers. Are these satisfying this condition P by Q? Yes. This 1 can be written as 1 by 1. 2 can be written as 2 by 1. Similarly, 3 can be written as 3 by 1. So everywhere we can keep the denominator as 1. So this denominator 1, which is nothing but this Q, which is not equal to 0. Now what are the whole numbers? Whole numbers are nothing but 0 plus these natural numbers. So 0, 1, 2, 3, 4, 5, and so on. These are all whole numbers. So again, these are also satisfying the P by Q condition. Yes, same as like natural numbers, we can write here 0 as 0 by 1, 1 as 1 by 1, 2 as 2 by 1, similarly, and so on. So next one is integers. So here integers 0, positive integers like 1, 2, 3, 4, and so on. Similarly, negative integers -1, -2, -3, and so on. So here this category 0 and positive integers are W, whole numbers, plus negative integers are known as integers. So here what we understand from this diagram, rational numbers are in the form of P by Q, where this denominator Q here, Q not equal to 0. So rational numbers are like fractions 1 by 2, 3 by 5, minus 7 by 9, and here everywhere these are in the form of P by Q. So Q is the denominator, this should not be equal to 0. So these rational numbers are categorized as fractions, natural numbers, whole numbers, and integers. So again, integers 0, positive integers, and negative integers. So natural numbers are, as we know, 1, 2, 3, 4, and so on. Again, these can be written as 1 by 1, 2 by 1, 3 by 1, and so on in the form of P by Q. Whole numbers also in the form of P by Q. 0 plus natural numbers. Integers, whole numbers plus negative integers. So integers represented with Z, whole numbers with W, natural numbers with N, rational numbers Q, irrational numbers Q dash or S, real numbers are R. So these irrational numbers are cannot be in the form of P by Q, where Q not equal to 0, P and Q belongs to Z. So here what does this mean, P and Q belongs to Z? These are here Z is nothing but integers. So P and Q are belongs to Z, integers, either 0, negative or positive integers. So whereas these irrational numbers are cannot be in the form of P by Q, where Q not equal to 0, P and Q belongs to Z. So this, if this is the case, then they are called as rational numbers. These irrational numbers are like root 2, root 5, pi, and so on. So these kind of numbers are irrational numbers. These are the category of real numbers at a glance. Now we can study about these number systems in the form of decimal representation, so which will give somewhat clear idea about irrational numbers. Yes, what is this? Decimal form of real numbers. So real numbers, as we know, categorized into two broadly, rational numbers and irrational numbers. So these rational numbers are terminating when they converted into this decimal format, or non-terminating, repeating or recurring. When these irrational numbers converted into decimal format, they are non-terminating, non-repeating. Let us understand this. What is this? So terminating in the sense here, for example, 0.125. So this is terminating. So after the decimal, 3 digits are there, 1, 2, and 5. So this is terminating. Similarly, 0.349 or 1.5, 7.8. So these are terminating. After the decimal, the number of digits are countable and these digits, these number of digits are not repeating after this decimal. These digits are not repeating, so they are known as terminating. Now what is this non-terminating, repeating or recurring? The same category, for example, you can consider this 0.125 is there, then 5555. So what does this mean? This means this is equal to 0.125 bar, where what is the digit repeated or recurring? This recurring and repeating means same meaning. So what is the digit repeated so many number of times after the decimal? So there we used to keep a bar on top of that. Similarly, another one we can consider. So here 0.333 and so on. This is equal to 0.3 bar. So here this non-terminating, repeating, recurring. Non-terminating in the sense these are not terminating. So after the decimal, digits are continuously repeating. Digits are continuously repeating. Of course, here 3 is continuously repeated, but in this example, after decimal, 1, 2, two digits are not repeated, then 5 is continuously repeated. So based on this repetition structure, again, this is this non-terminating, repeating, recurring case. This one categorized into two. What is that? Pure repeating. Pure repeating in the sense like this kind of example. So here you can consider 0.53 bar. That means after the decimal 0.53, 53 and so on. You can consider one more example, 1.3 bar, which is equal to 1.333 and so on. So here in this case 1.34999, one example and so on. So this is equal to 1.349 bar. One more example, 0.5333. This is equal to 0.53 bar. So here what you can observe, after the decimal, in this case pure repeating case, after the decimal what are the digits are there? Here 53, those 53 are continuously repeating. Here after the decimal 3 is there, that 3 is continuously repeating. But here in this mixed repeating case, after the decimal 2 or at least one digit is not. Here 5 is not repeated, 3 is continuously repeated. Here 3, 4 is not repeated, then 9 is continuously repeated. So after the decimal, at least one digit is not repeated, then remaining digits are repeated. That is called mixed repeating. And after the decimal, all the digits are continuously repeating, then that is called pure repeating. So now what you understand from this decimal form of real numbers, what we have understand here, these rational numbers are broadly two types, either terminating decimal or non-terminating repeating decimal. So the decimal equivalent, when the rational number converted into decimal equivalent, either it can be terminated, where we can see remainder as 0, or this repeating structure, either repeating case it is pure or mixed repeating, whatever it may be, repeating structure we can see. But whereas in this case, irrational numbers, non-terminating, non-repeating, we understand this scenario, we understand that. So here 0.53 is continuously repeated here. So here 3 is continuously repeated. So here from this scenario we understand what is repeating structure and what is non-terminating structure. So here these are purely terminating. So that means digits after decimal are not repeating in this kind of scenario. But here in this scenario, digits after decimal are repeating. So that means that is non-terminating. So at the same time, this one non-terminating, non-repeating. So that means after the decimal, digits will not have any particular format. Non-repeating. For example, you can see here 1.5431256 9 and so on. See here. So this is non-terminating, and this is non-terminating and also non-repeating. So here this word non-repeating means we don't have any specific structure, something like this. So here bar, 9 bar. So 9 is continuously repeated here. And here 3 bar, 3 is continuously repeated. Here 5 3 bar, and here also 3 bar. So here some digits after the decimal where we have continuously repeating. But here in this kind of scenario, this is non-repeating, this is non-terminating, at the same time non-repeating, 5 4 3, some random order. So we can have many example for this. So 1.01 001 001 00001 and so on. This is also one more example. So these are kind of different examples. This is example 1 or example 2. Like this we have so many number of examples for this non-terminating, non-repeating. So here in this kind of scenario, like root 2, root 5, pi, all these values are actually non-terminating, non-repeating. Pi value is 22/7, that is approximated value. It is not exact value. Similarly, root 2 we used to use like 1.4, that is also like approximated, not exact value. So these values are like non-terminating, non-repeating. So this is the decimal form of real numbers overview. Now we understand that what are the real numbers, how they are helping us, and we know that basic building blocks of maths are sets and some group of sets. One set or some group of objects are mapped to some symbols. So with only one pencil mapped to 1, and some objects like 2 mapped to 2, and these many number of objects are mapped to another symbol called 3. So these 1 2 3 9 are symbols. So for these symbols some group of objects were mapped, then the number system was invented. So from the number systems we studied that real numbers, and the real numbers fractional and non-fractional, in the sense rational and irrational. So decimal form of real numbers also we understand. So now irrational numbers cannot be represented in the form of p by q, where q not equal to 0, p and q belongs to z. And also this decimal representation of irrational number is non-repeating, non-terminating. This is important point, which is non-terminating, non-repeating. Whereas on the other hand, rational numbers are either terminating. If it is not terminating, then but whereas irrational number is non-terminating, non-repeating. So this is a kind of overview of decimal form of real numbers. Now let us understand the fundamental theorem of arithmetic.